Hi, I'm Mason Vale from Boise State University, and in this video I'm going to talk about designing and developing a test suite for implementations of the indexed unsorted list interface that we use in our CS2 course. The process of developing a test plan for any abstract data type begins with studying the interface, reading through all of the documentation. So if you haven't done this already, you need to open the IndexedUnsortedList.java file and read through all of the documentation in there. So in general, the indexed unsorted list interface defines an iterable list that blends basic unsorted or unordered list functionality with indexed list functionality and methods that are expected out of all Java collections, things that are in the Java Collections API. Once we're familiar with the overall ADT concept and all of the methods that are available to us in the abstract data type, we can start building a map of all of the change scenarios or test cases, beginning with the most simple basic test case, which is a newly initialized empty list right after the constructor has been called. From there, we can use the change methods that are available in the ADT to start mapping out all of the ways that I can go from an empty list to a single element list, from a single element list to and back to an empty list, from a single element list to a two element list, and so on, building up in complexity as I go. This is a partial map that I use to start identifying the change scenarios for an indexed unsorted list. So I began with my first scenario. I had no list. I called the constructor and I got an empty list. From an empty list, I identified four possible ways that I could change this list. I could call the addToFront method to get the first element into an empty list. I could call the addToRear method to get the first element into an empty list. I could add a new element at index 0. I could add A. So there were four ways I could get the first element into an empty list. Each one of these is another change scenario. So we're up to 5 change scenarios. From a list containing a single element, I could add another element in multiple different ways. So I've got more branches from a single element list that take me to a 2 element list. I could also take a single element list, as in this case, and I have 4 possible ways that I could remove that one element and get me back to an empty list. So each of these is a new change scenario that takes me from a single element list to an empty list. From a 2 element list, I can remove elements, or I can add another element. And there are more ways that I can add a third element than there were ways that I could add a second element, because there are more possible positions where I can do adding. So this is only a partial list. I'm missing some set methods that would allow me to change values. And from a 3-element list, I would need to include all of the ways I could set to change existing values or remove to get back to a 2-element list. I would find that to be necessary just to have a minimum set that would make me feel like I'd covered most of my boundary cases and equivalence cases. After following that mapping process, these are the 43 change scenarios or test cases that I came up with, where all of these test cases involve a list that's no bigger than 3 elements. So I stopped at 3 elements because a 3-element list is the smallest list that has a distinct beginning and a middle and an end. So I identified a 3-element list as being a good basic starting point for equivalence cases that involve lists that have a distinct beginning, middle, and an end. Any good test suite should include all test cases that are critical boundary cases. So for the purposes of this list, those would be changes involving an empty list, either as a starting point or an ending point, any changes that involve a single element list, beginning or ending with a single element list, and any change to the beginning of a multiple element list or changes to the end of a multiple element list. So those would be boundary cases, and those should be in any good test suite. I also need equivalence cases for any expected general scenarios. For example, any change to the middle of a multiple element list would be something that I would want to cover with an equivalence case. As I already said, I've identified a 3-element list as the smallest list that has a distinct beginning, middle, and an end. So I would want to include all cases that involve 3-element lists as well. So that means that I would argue that all 43 of those change scenarios that I identified on the previous slide make up the minimum set of boundary and equivalence cases that I would want in a test suite if I were going to put my implementation into a production environment. Now, this still isn't a complete test case or a test suite. If I had more time, I would want to include some smattering of test cases that include much longer lists so that I can be sure that size isn't an issue. I also don't have any test cases in that plan so far that involve duplicate values. Lists and allow duplicates. So these 43 are really a starting point. I would really want, if I had time, to include more change scenarios than just these before I were to test this in a real production environment. Now that we've identified the actual change scenarios that we want to test, now we need to define the actual tests for each of these scenarios. In order to do this, for each scenario, we need to include a test or multiple tests for each of the methods out of the IndexedUnsortedList ADT. And we make these tests based on the expected resulting state of the list after that one change. We need to include both valid and invalid method inputs for each of these methods as appropriate. For example, if I were doing something with indexes, I would need to include indexes both inbounds and out of bounds to confirm that I get the right results from this indexed method at all of my boundaries. For example, this would be the set of tests that I would identify for our very first case, the brand new, newly initialized empty list after the constructor has been called. I have tests for adding the first element, adding to front, adding to rear. I would expect those to work. They shouldn't throw any kind of exception. I would expect that I cannot use the add after method because there are no elements in the list currently that I can add after. I would expect that I can't remove using any of my methods because there's nothing in the list that I would be able to remove, so I expect specific exceptions to be thrown according to the method documentation for each of those remove methods. I would expect that I'm not able to use the set method because I can't replace something that doesn't exist. I don't expect that the get method will work because there are no values that I can legitimately get. There are no indexes that are inbounds for an empty list, and so on. So for each one of the ADT's defined methods, I'm attempting to call each of those methods using valid and invalid values as appropriate to confirm that under all circumstances, if I call this method, I will get the expected result. For a change scenario that results in a longer list, you can see that the number of tests increases. When I had an empty list, there were very few positions that I could work with. When I have a 2-element list, there are more positions and more values that are in bounds, and so my total number of possible tests has increased. When I'm adding after, for example, there are actually 2 values now in the list that I could add after, and they both need to be tested. I need to know that I can add a C after element B. I need to know that I can add C after element A. I still need to confirm that I can't add C after D because D is not in my list. So there are more tests now for a 2-element list than I had for a 3-element list. Some of those set values and get values, the indexes that were not valid in an empty list, are now valid. And so I'm testing at each of my indexes, I'm testing inbounds indexes. 0 and 1 are both inbounds for a 2-element list, but I'm still also checking the first values that take me out of bounds. I'm testing my boundaries to confirm that -1 and 2 are invalid indexes for my 2-element list. Now that I've identified my set of change scenarios or test cases, and I know all of the tests that go with each one of my change scenarios and their expected results, I have a test plan. So now I'm ready to start implementing all of this test plan into an executable test suite so that I can begin development. Now, there are many ways that I can implement a test suite, and they all have their advantages and disadvantages. In a production industry setting, usually a high-powered testing framework like JUnit or TestNG, they get used because they have great advantages. They can be integrated into comprehensive building systems. You can use them to generate automated reports every time the tests are run. There are a lot of advantages, but they also have a great deal of overhead, and they all have their own learning curve. So we are going to be using, for CS2, we're going to be using a standalone test class rather than one of these industrial strength frameworks. We're doing this so that we can avoid adding an additional learning curve to our challenge. We don't want to take the focus off of learning about the concepts around testing. We want to understand the purpose of testing and the processes around testing. Once you understand testing in general, learning a particular framework later on will be less difficult because you will understand all of the underlying concepts. One of the challenges that's imposed by test frameworks is often that they involve many different classes. Usually there's a full class for each one of the test cases. So if I had these 43 test cases that I've identified so far, that would be 43 or more 43 or more classes that are part of my project, which adds to my navigation and project management challenge. And finally, this is maybe the biggest one, the biggest justification for not using one of these frameworks, is that if you're debugging and you're stepping through all of the methods that are involved, when you add in the classes that are involved in the framework itself, you're having to navigate through a lot of code that's not actually part of your project, and that adds great complexity and a lot of layers to your debugging challenge. So in a production environment, this is somebody's specialty, somebody's job, and all of that overhead can pay off in a large production environment because of the automation and the reporting and all of that. But for our purposes, we want to keep our focus on the concepts of testing, and we want to ease the debugging challenge as much as possible. So we're going to use a standalone test class that's self-contained. Everything will be inside one class for the debugging process, and that's going to make it a lot easier for us to do our project development. The standalone test class we're going to use is called ListTester, and it includes a lot of code that we'll need to get acclimated with. It is set up to test any implementation of the IndexedUnsortedList interface. So we can configure it to test any class that implements that interface. So in order to choose which class we're testing, there is a constant near the top of the file called list2use that needs to be set to an appropriate value so that it chooses the correct constructor to begin all of this testing. So we need to make sure that we've set list2use to an appropriate value, and we also need to make sure that the constructor associated with that list2use is enabled in the newList method. So this is a look now at the ListTester class, and I will warn you in advance, it is a little overwhelming at first. The amount of code that's given at the very beginning already includes 1,607 lines of code. So there's quite a bit that's in here already. Probably the first challenge that you'll have is simply getting oriented to where the code is inside this class that you actually need to care about and what code you don't need to care about. So at the top here, we're going to do this a step at a time. We can see an enumeration called list2use, and this includes your choices for the possible implementations of the lists that we might want to test this semester. We will have a good list, a bad list. These are just samples that are given as tests, just for testing purposes. We also have the 3 implementations that we will be writing this semester. We'll have a version of an array list, we'll have a version of a single linked list, and we'll have a version of a double linked list, all of which implement the indexed unsorted list interface. So these are all choices. In order to know which list the test class is going to test at this time, we use the list2use constant. So I need to choose one of the values from the list2use enumeration to decide which one is being tested. And right now I've selected good list. As you're testing, you'll pick whatever it is that you want to test. So I had to select something here, so I'm choosing good list. So I also need to find the newList method. The newList method is where I choose which constructor to call, and I do that based on which list to use I selected up here. So if I scroll down past some utility methods, I find, here we are, a set of methods that I've called scenario builders. So these are the methods that create my lists that I want to test. So the very first scenario builder that I have to have is the one that creates a brand new empty list, and that's the newList method. This is the only method in the entire ListTester class that includes constructor calls. So right now, the only two lists that I have in my project, my list project, are my good list and bad list implementations. These are handouts that are included with the beginning project for testing. So I'm currently set to use list to use good list, so I have a switch case that will match this good list case, and I'll end up calling the constructor for the good list class. If I had chosen bad list, I would be calling the constructor for bad list. And as I start developing array list, single linked list, and double linked list implementations, I can uncomment those and make them valid constructor calls as well. So that's my first step, is to identify what list do I want to test, set that list to use variable so that I'm testing the correct version of my list, and I need to make sure that the constructor that goes with that list to use is enabled in my newList method. To start implementing my test plan now, I need a method for each one of my change scenarios, each one of my test cases that builds the list that I want to test. So we've seen one example of that so far. We've seen the newList test for my very first change scenario. And I can use that as the foundation, as the starting point for every change scenario that begins with an empty list. So I need now a scenario builder method for each one of my change scenarios that starts using an existing scenario builder method as its starting point. It calls the one change method that is the key to that particular change scenario, and it ends up returning that resulting list. Now the way we're going to use these is we're going to pass them in as a reusable resource for all of our set of tests. So in order to pass a method to another method as an argument, we need to create what's called a lambda reference. And don't worry, you don't have to understand what that exactly means, but we need to create an associated lambda reference for each one of our scenario builder methods. For our newList method, directly below the definition of the newList method, I've put in an extra line that creates a lambda reference that has really the same name, same identifier as the newList method. This line creates a reference that says that the newList variable that I'm defining here refers to this newList method. So I can use that later on when we start calling the actual tests. So let's look at an additional scenario builder that's given as an example here. So this is the empty list addToFront A scenario builder method. It represents the scenario that begins with an empty list, calls addToFront A, and results in a list that simply contains A. So the naming that I'm using for my scenario builders maps to the way that I described a starting state, a change, and a resulting state. So empty list is my starting state, addToFront A is the method that I'm calling, and A is the contents of my list after I've called addToFront A. So this is the method that creates a list that results in A after calling addToFront A. So I need in every one of my scenario builders 3 statements. The first statement gets a list that represents my starting point. So my starting point is an empty list. I already have a scenario builder method, newList, that gets me a new empty list. So I begin by getting a list of my indexed unsorted list type, and I get it from the newList builder method. That's my starting state. The second statement inside my scenario builder is the one change that I make to my list for this change scenario. This is where I call my addToFront method, and I call it using element A, which is a constant defined above. So after I've begun with this starting state and I've made my one change, I expect that my list now contains element A. I believe that I have the resulting state of this change scenario, so that is the list that I return. And just as I created a lambda reference to the new list method, I'm going to create a lambda reference for empty list addToFront A. So here I define a scenario, empty list addToFront A, same name as the method but without parentheses, and it refers then to my builder method. So every change scenario is going to have a builder method, a builder method that has a clear name that goes with that change scenario, and it has an associated lambda reference with the same name. In a method called runTests, I'm going to match up each of those scenario builder methods that we've already defined with its appropriate set of tests. For each particular size of resulting list, there will be a matching set of tests. For example, that scenario builder that we just looked at, empty list addToFront A, it results in a list that contains one element. So I'm going to use the scenario builder that I created and pass it as an argument to another method called testSingleElementList that contains all of the tests that are appropriate for a single element list. Along with that scenario builder, we'll also be passing in to the testSingleElementList method, we'll be passing in a set of strings that represent the scenario builder and its expected contents, and that's simply for printing purposes so that we can print output that we can read to the console. We'll also be passing in an array that contains the expected contents of our scenario builder. runTests is found above my scenario builders. Here we are. This is the runTests method. And inside the runTest method, we find those matched sets of tests and scenario builders. And I've put them in order of increasing complexity. So at the beginning, I'm going to start with my newly constructed empty list. A new empty list is an empty list, so the set of tests I will use is the test empty list. I pass into an empty list my lambda reference to the new list method and a string that is the name of that scenario builder. So this string will appear in my output, in my test results. So I want it to match the name of the scenario builder that I'm testing so that if something goes wrong, I can quickly find the appropriate scenario builder that goes with that string. So that's my very first match between a scenario builder and the set of tests that goes with a list that size. I also have several examples here of single element lists. So here's our empty list addToFront A passed into the test for single element list. And I have a matching string that goes with that name. Afterward is where I find the expected contents of the list. So the way we're going to be reusing the same set of tests but for different lists is by passing in the expected values so that the tests can compare the values that I find from this particular list to the expected contents. That way I don't have to have all of my tests written out individually by hand for every single one of my scenario builders. That would result in thousands and thousands of duplicated methods. So I don't want to do that. So I'm passing in an array that has the expected contents of my list. So for each end result, for each resulting list, there will be an array defined up above. Let's see if I can scroll that over. So I have here an array of integers that contains my expected contents. So list A contains just element A. List BA down here would contain element B and element A. So for every end result that I would have out of any of my scenario builders, I will have an associated array that has the contents that I expect out of that list. And I also have a string, again for printing purposes, a string that shows the contents of my list so that I can use those in my methods for output. So several matched up scenario builders and their associated set of tests are given in here as examples. And then I have placeholders for different categories of different sizes. So I would place all of my tests that began with an empty list and resulted in a one-element list. I would group them together. I would have all of the tests that begin with a single element list and result in an empty list. I would put those under the next category. Here's my last example, was a one-element list that results in a two-element list. I began with a one-element list. I resulted in a two-element list. So they get more complicated. Remember, there were those 43 change scenarios. So they begin with certain sizes, they end with certain sizes, and I group them together to make management a little bit easier and navigation a little easier. They're also in order of increasing complexity, and that's not by accident. I want to start with the simplest possible scenario. If I can't get past initializing a list, nothing else matters. If I can't get past adding the first element to an empty list, nothing else after that matters. So I would always begin my testing with the simplest scenarios and only work up in complexity after I've passed all of the tests for the scenarios that my more complex tests build on. So they're in order of increasing complexity. So as I create scenario builders, I will come up to the runTests method and I'll add in the call that tests that list using its expected contents. So as I've said, for each sized list, there is a method that contains all of the appropriate tests for a list of that size. So there is a method for empty lists, one element list, two element list, and three element lists. Now I've given as examples a complete set of tests for all of the methods out of indexed unsorted list, a complete set of tests for empty lists and single element lists. So those are given as examples. You won't have to write any tests in the test empty list method or the test single element list method. You're going to follow, however, the example that I've given and build up the set of tests for two element and three element lists. So those are not yet complete. There are method stubs in place, but they don't have any actual tests in them yet. So that's going to be your responsibility. So after my scenario builders is where we find our sets of tests. So here's the first one. This is the set of tests for empty list, test empty list. And it receives as an argument that lambda reference that we created to a scenario and the scenario's name that we can use for output. And inside a try block, we have a print method that's going to print the result of each individual method test. These can get fairly deep, so it will take a little bit of time to get acclimated to how this works. The print test starts with printing the string for our scenario name and the particular test that we're going to run. So this output will help you with debugging. It will help you find the exact test that was failing. Right here is where we actually call a test, a single test for a single method. And there's one of these for each one of the methods out of our interface, and there's a method call for each one of the valid and invalid inputs. So the first thing we're testing here is the remove first method. And the remove first method test takes in as arguments the scenario.build. Scenario is that lambda reference, and the build method accesses the actual scenario builder method. So this gets us the method that we're supposed to use, and it returns the list that's been newly created. So our scenario builder method gets called, and we end up with a list, the list that we're supposed to test. Each one of these test methods has, after the scenario builder itself, has expected values. So if I expected to actually receive a value from the remove first method, I would pass in a reference to a matching value in this position. I also have an expected result from each test. The result I expect from an empty list, if I call remove first, is a specific exception. I expect a no such element exception because that's what the documentation for that method tells me to expect if I've called remove first on an empty list. So I'm passing in a list, an expected value, and an expected result to test remove first. And if the result that I get by calling remove first on my list matches the expected result, then my test passes. If I get anything else, the test is going to fail. So you can see down this line, as I call all of the different tests that go with my interface methods, I'm passing in sometimes a specific result, sometimes I'm passing in a specific result that's expected or that is a necessary parameter. If I'm adding to front, I need something to add to front. So I'm passing in element X here that I'm trying to add to the front of my brand new empty list. And the expected result is no exception. I expect no exception from this method call. So it's going to take a little while to navigate through and become familiar with how these tests are being called. And you may need to refer further down in the code to find these specific methods to see what they expect. If I hover over that method, I can also see the Java doc that goes with this method so that I can see what are the expected inputs. I'm expecting a list, a target integer, an element, and an expected result from this method. I realize that's very small, but you can hover over these methods to see what they expect, and you can look down below in the code at the individual method to see exactly what it's doing with these input values. So you know what to pass in based on the test plan you've already created. I know that for an empty list, if I call addAfter, it doesn't matter what I have as my target element or what I have as my new element that I want to add, the expected result of calling addAfter on an empty list is a no such element exception. So that's my test right there. I can tell what I'm supposed to get based on my test plan. I know I should get a no such element exception. So that's for my set of tests for empty lists. I'm also including a set of tests for an iterator, which we haven't discussed yet. So after we've talked about iterators in more detail, we will get into more detail about how to test iterators. There's also another iterator called a list iterator that will only be implemented for a double linked list. So currently, for a list iterator, I expect that all of my tests are going to be throwing an exception for an unsupported operation exception. So for the time being, you can really ignore the iterator and list iterator tests. We're just focusing at this point on tests that involve our indexed unsorted list interface. So this is the set of tests for an empty list. And I've given you all of those tests. I've also given you all of the tests that go with single element lists. So there are more tests for a single element list because there are more valid positions and there are more valid values that need to be accounted for in my tests. So I have a complete set of tests for single element lists that are given here. There's also more iterator tests. We'll get to that later. What you will need to do is provide tests for 2-element and 3-element lists. So this is the test 2-element list method, and right now there are no tests. You'll need to follow the pattern that's demonstrated by the test empty list and the test single element list methods to develop a set of tests for 2-element lists. The good news is you only have to do this once, and then you'll be able to use this method for all of the testing for all of your 2-element lists. So it only has to be done once. So we referred to some of these elements and some of these return values. So I want to go back up to the top of my class here to show where those are defined. So all of the possible results for any of the tests for our methods are represented by one of the values out of this enumerated type result. So I start out with one result value for each of the possible exceptions that can occur. Here's an index out of bounds exception, illegal state exception, no such element exception, concurrent modification exception, unsupported operation exception, no exception, and some unexpected exception. So most of these values represent some kind of exception or the lack of an exception. I also have the possibility, if it's a Boolean test, it could return true or false. So I might have an expected value of true or an expected value of false. I have some tests that are just pass or fail. I just want to know if my test passed or my test failed. If there's an expected matching value, if I'm removing a certain value and I expect a certain value to be removed, the matching value will be the expected result. For my string tests, I just want to know maybe if it's a valid string, because strings are very difficult to test. So I just want to know if it's a valid string. So all of the possible results from all of my tests are represented somewhere in this result enumeration. I also have identified a set of constants for all of the values that I might want to store in my list. And I've done this to abstract away the fact that these are They have to be something, so I made them integers. And I wanted them to have distinct values, so they all have distinct values. For the purpose of testing, I don't care that they're integers and I don't care what their values are. All I care is that I have different objects that I'm storing in my list. If I came back through and replaced all of these with strings or with any other data type and gave them different values, all of my tests would still work just fine. So I'm trying to abstract away the fact that it's integers so we don't fixate on numeric values. But everywhere you saw in our descriptions, our test descriptions, and our possible values that are contained inside of a particular list, we'll just use element A, B, C, and so on. So the reason I have more than just A, B, and C is that sometimes I want to, for example, if I have a list that contains 3 elements, I might want to add a 4th element, just to make sure that calling add, is acceptable. So element D is a new value that I might add to A, B, C. I might also want to replace a value in a list that only contains elements A, B, and C. So if I want to replace a value in an existing 3-element list, I might use element D to do that, because it's different. I would be able to recognize that I successfully used the set method to replace A, B, or C with a D. I also have 2 values that represent elements that should never appear inside my list. So if I'm ever using, for example, addAfter, and I want to confirm that if I call addAfter and I provide an element as the target that is not actually in the list, I would use X or Z, just so that they're different, something that I know is never in any of my example lists. So X and Z exist as references to elements that should never appear in any of my lists. So that's why I've got these defined up here, and so I would recommend that you use these constants exclusively through all of your test code and never refer to an integer by its particular value. We don't care that they're integers, we don't care what their number is, we only care that they are unique elements in my list. Something else that I want to just point out before we end this, I referenced that there are tests that are supplied for each one of the methods, and so down below my test single element list, 2-element list, 3-element list, I have the individual test methods. So for example, grab remove first. So here's the test method for the remove first method. The remove first is from the abstract data type. So each one of my test methods expects the list that it's supposed to test. So this is the reference to a list that came from one of my scenario builders. For the example of remove first, we expected a particular return value, something that the remove first method should return. So there's a reference to another integer, an expected element. And then there's the result that we expect from this test. So we were looking at an empty list. We passed in a null reference here because if I have an empty list, I expect nothing from remove first, so there's nothing to compare it to. And our expected result was a no such element exception. So the way each one of these test methods works, I've passed in my list, I've passed in any parameters that I need in order to call this method and compare results, and I have an expected result. These are all working with try-catch blocks so that I make sure that no test can crash the test suite. So inside the try block, where our dangerous code goes, we are getting the result of calling the remove first method on the list that was passed in. All of the tests begin by calling the method that they're supposed to be testing on the list that was passed in. It's in a try block, so if something goes wrong in the course of calling this method, I would try to catch the expected methods. The remove first method is expected to throw an exception if the list was empty. It's expected to throw a no such element exception. So one of the catches that's in this test is catching a no such element exception. If I get a no such element exception, I'm setting the result of this test equal to result.noSuchElement. And at the end of this test, I'm comparing the result I got to the result I expected. And if they match, I'll return true. If result that I got equals the result I expected, this test passed. I passed this test, I'll return a Boolean true. If I were to call list.removeFirst on an empty list and I did not get an exception, I would try to compare the return value I got to the value of the expected element that was passed in, and I would see if they matched. If they matched, I would get a matching value result. If I got anything else, the result of this test is a failure. If I threw an exception up here, but it wasn't a no such element exception, there is an additional catch block, an additional exception handler that would catch anything else, and anything else would be unexpected. This is the only exception I ever expect out of a remove first call. So anything else would be caught. I would print the results that I caught an unexpected exception, print that exception, and the stack trace that goes with it for debugging purposes. And the result of this test was an unexpected exception result. So when I got to the bottom and I compared the result I got, an unexpected exception, to the result I expected, I didn't expect an unexpected exception, I would end up getting a false. This test would fail. So this test is an example of a method where all possible paths that I care about are represented somewhere. So it's a reusable test for any list as long as I pass in a list, the appropriate expected value, and the expected result. I can match any expected result if I got the right results. And all of the test methods are set up that way. All of the possible paths through this test, all of the possible results I could get from calling the particular method are represented somewhere inside this test, and I end up returning a result where the result I got is compared to the result I expected. So the only way to pass the test is to get the result I expected.